In this video, we're about to look at resolution to partial fraction, and we'll say that the process of transforming a compound fraction into the sum of partial fraction is called resolution to partial fraction. Now, what does this thing mean? This thing means when you have a compound fraction of this form, this is a compound fraction. The act of transforming this compound fraction now, this is an algebraic fraction, right? A proper algebraic fraction. The act of transforming this thing into the sum of partial fraction is called resolution to partial fraction. Now, what does this thing mean? It means that if you're able to write this guy as, let's say, a fraction of this form, if you're able to write this fraction as this form now, it means that you have resolved this fraction into this partial fraction. These are called partial fraction because they are in the simplest term this fraction could be. So when you sum up these two, you get back this compound fraction. That is what resolution to partial fraction is all about. Now, if you observe very well, you see that the partial fraction is basically determined by the denominator of the compound fraction. Because if you are able to factorize this thing into linear factors this way, then we're able to tell what the partial fraction could be. So in essence, the denominator of the compound fraction determines majorly what the partial fraction would be. So let's just look into concrete example. If you have to resolve this to the partial fraction, it means that if you write this thing as the ones we just clean now. So basically, you have to factorize this denominator if it is factorizable. If it's not factorizable, we follow through another approach. But in this case now, see that it's factorizable, and when we factorize it, we see that is equal to, we just rewrite this numerator and say that this denominator, when we factorize it, to have x squared plus 3x plus 2x plus 6. Then we factorize it this way, so that we have that 7x minus 9 over, we bring out x here, we have x bracket x plus 3, and here we have plus 2 bracket x plus 3. So this fraction now becomes 7x minus 9 over x plus 2 x minus x plus 3. So we can write this in as a partial fraction of this form, a over x plus 2 plus b over x plus 3. Now, what we did here is that we assume that if this is a compound fraction, then the partial fraction will definitely look like this, right? Now, the main work here is to find the value of a and b. When we find the value of a and b, by comparing this side with this side, because they are equal, we say that we have resolved this compound fraction into its resultant partial fraction. Exactly. So let's proceed to solving this problem. So after we factorize the denominator of the compound fraction we started with, we got this as the factors. When we multiply this, you still get back that quadratic denominator. So here now we now assume that this is equal to a over x plus 2 plus b over x plus 3, because we say that partial fraction resolution is to write a compound fraction as the sum of the partial fraction. So from here now we can take the LCM of this one and say that is equal to a multiplying x plus 3 b multiplying x plus 2. So this is over x plus 2 x plus 3. So from here now we can equate these two. I'll say that 7x minus 9 over x plus 2 x plus 3 is equal to, when we open up this bracket now, we compare coefficients, because if this is equal to this, that means both the numerators are equal and the denominators, they are equal as well, because these denominators are the same thing. So here we have ax plus 3a plus bx plus 2b over x plus 2 x plus 3. So from here we can proceed by comparing the coefficients, because when we bring the x together, from here we see that, okay, by comparing coefficients, you can clearly see that 7 is the coefficient of x here. is equal to a plus b. That is this and this, right? And the constant term, so that minus 9 is equal to 3a plus 2b. So that this has led us to a simultaneous equation which we can solve by either substitution or elimination. So we proceed now to solve it by elimination and see the result we get. So this one will multiply by 2. So that 2b plus 2a is equal to 14 and 2b plus 3a is equal to minus 9. So we can proceed to subtract the both of them. When we subtract this now, we have this and this will go. That means we are eliminating. So this minus this will give us minus a, and is equal to this minus this will give us what? 23. So that a is equal to 23 minus 23 because we divide by negative. So from here now we can substitute the value of a in this case here from this equation. So that b is equal to a 7 minus a, but we know the value of that minus 23. So b will be equal to 7 minus 23, which is same as saying 7 plus 23, which is equal to 30. So say that b is equal to 30. So now this for this compound fraction. Now we have seen that the partial fraction is this. We substitute the value of a and b back there. So we say that this is equal to instead of this part, this is now equal to a is what? Minus 23 over this x plus 2 plus 30 over x plus 3. So this is the partial fraction for this. Now this is the simplest form a fraction can be. Like this fraction now, you can't break it further than this. Like this is the simplest form it could be, and that's the partial fraction. Now for us to know if our answer is actually correct, we try to sum this thing if we can get back the compound function we started with. So to try that, we can just say this, the LCM is this. So we have minus 23 multiplying x plus 3 plus 30 multiplying x plus 2 over the denominator x plus 2 x plus 3. So when we open this one, we will say minus 23 x minus 69. This one give us plus 30x plus 60 over the denominator x plus 2 x plus 3. So when we collect like terms here, we say that from here we have 7x, then this minus this, we have minus 9 over x plus 2 x plus 3. So that this is the same fraction we started with. So this guy here is the partial fraction to this compound fraction here. That means when you sum up these things together, this is what you get, and this is just how to solve partial fraction. So let's proceed to solving more example of partial fraction. So we have this problem here before us. We have to resolve this into partial fraction, and like we did in the previous one, it's just the same method. Don't be confused with just having only a constant term here. You follow it through the same process. So first thing you are going to look at is the words denominator. Yeah, you look at the denominator. This denominator is a polynomial, and by using the discriminant, so that it is factorizable, right? This is factorizable, and we'll see that when we factor it, you have 3 over the factors of this are x plus 1, x minus 2. So these are the factors. You can pause the video and factorize this and see that these are the factors you get. So you can just proceed to say that this will give a partial fraction of this form: a over x plus 1 plus b over x minus 2. Yeah, so we're having only 2 linear factors here. That's why we have only a and b and c. Let's say we have a and b. Let's say we have 3 linear factors here. We're going to have a, b, c. If we have n linear factors, we are going to have a, b, c up to n. Is that clear? Yes. So from here we just proceed the usual way. So we say 3 over x plus 1. Let's just write it this way: x minus 2 is equal to when we take the LCM of this one now, we have x plus 1, x minus 2. So we say that this a bracket x minus 2 plus b bracket x plus 1. Now, for those that may be confused, the reason we do this in this way is that the LCM of this partial fraction and this partial fraction is this times this, right? That's the LCM. So if we now say this LCM divided by this, now we are left with what? X minus 2. So we now use that x minus 2 and multiply this one. It's just the same way you do it in normal numerical fraction. There's no difference between the numerical and the algebra. I know you may be looking something different. It's not different, it's the same thing. We take this one here, divide it by this, we are left with this, we use this and multiply this one up here. So that's the same process. So we can proceed to open up this bracket. When we open up this bracket, we have ax minus 2a plus bx plus b. This over x plus 1 x minus 2. So from here now we can see that we can compare coefficients. When we say 3 over x plus 1 x minus 2 equal to, so from here we say that a plus b are coefficients of x from this right hand side, and minus 2a plus b, these are the constant terms. So this is over x plus 1 x minus 2. So we can see clearly that now in this case now this is a constant, right? So we see that we have something like 0x here plus 3. The coefficient of x here is 0 and the coefficient of x here is what? A plus b. So we can just proceed and say a plus b, we are comparing coefficients, is equal to 0, right? Then we can see from here that 2a minus 2a plus b is equal to 3 by comparing coefficients. This is the constant term, this is the coefficient of x. The coefficient of x here is what? 0. Like, normally we are not meant to write 0a, but I want to just know that anyone that is not there, its coefficient is 0, because 0 multiplying anything becomes what? 0. So this is the coefficient of x here is 0. So we can still proceed to solve this by elimination, by subtracting. When we subtract this minus this, we are having a minus minus 2a, which will give us what? 3a. b minus b will give us 0. 0 minus 3 will give us what? Minus 3. So we have this over 3 over 3. So having a is equal to what? Minus 1, right? So from this one now we see that b is equal to minus a, or a is equal to minus b. So but we already have a here as what? Minus 1. So we can say that b is equal to minus 1, which will give us what? 1. So I've gotten the value of a as minus 1 and b is equal to what? 1. So we bring them and substitute them back here, so that this our partial fraction will be a is what? Minus 1 over x plus 1 plus 1 over x minus 2. So you see that this is now the solution for the partial fraction, so for this compound fraction. So we can proceed to verify this our answer if it's actually correct. That means we sum them up if we can get this compound fraction here. So I'm going to clean this place and evaluate this one, so that we'll see if it's going to give us this particular one. To verify if this is the solution of this partial fraction, we just proceed by what? Summing it up. When we sum them up, we say we have 1 multiplying x plus 1 minus 1 multiplying x minus 2. So this over x minus 2 x plus 1. So when we open up this, we have x plus 1. When we open up this, we have minus x plus 2 over x minus 2 x plus 1. So see that this will take away this, and we are having 1 plus 2 here, which is what? 3. So we are left with 3 over x minus 2 x plus 1, which is the same thing as this, or this, when we open up this denominator here. So we see that this is the compound fraction, while this is what? The partial fraction for this compound fraction. So let's just see one more example of this case. Okay, so from this problem here, we have to resolve this into partial fraction, so that the work was made easy because the denominator was factorized. So we don't have to go through the process of trying to factorize the denominator. We just quickly compare them and assume that this is, we should be of this form, 3x minus 1 plus b over 2x plus 3. Now, this is how this form could be. Now, why we do this way is that when you look at this fraction, right, it is proper. How is it proper? It's proper because the degree of the numerator is less than the degree of the denominator, and that is a condition for a compound fraction to be able to resolve. If you have an improper fraction where the denominator is less in degree than the numerator, you cannot resolve it into partial fraction directly. Now, another thing to note is that this one can be the denominator can be written as multiple of linear factors. That's why you can easily write it this way. Our partial fraction and our compound fraction are always proper. If you look at this thing we are assuming here, there's no value of x here. Why? Because this partial fraction, the numerator must be 1 less than the denominator, at least 1 less than the denominator. So that being said, we can proceed to resolve this into partial fraction. Now, so from here we can easily solve this by saying that this is equal to a multiplying 2x plus 3. Like this place now we are taking LCM, plus b multiplying 3x minus 1. This is all over 3x minus 1 2x plus 3. So from here we can easily open the brackets in the numerator and we equate it to this. So we'll say 7x minus 1 over 3 3x minus 1 multiplying 2x plus 3. We say that this is equal to, we have 2ax plus 3a plus 3bx minus b. This is all over 3x minus 1 2x plus 3. So from here we can decide to group them together so that it will be clear. Let's say by grouping I mean they're saying this is equal to 2a plus 3bx. Are you following? Like I brought the coefficient of x in this one and this one, like I'm collecting likeness. Now when we multiply this now, we get back these two things now. So this plus now the constant term plus 3a minus b over this now 3x minus 1 2x plus 3. So from here we can easily compare coefficient because this is the coefficient of x in this one and this is the constant term. So if we are to compare coefficients, you see that the coefficient of x here is 7 while here is 2a plus 3b. So we can compare them and say 2a plus 3b is equal to 7, right? Then the constant term would say 3a minus b is equal to minus 1. So again, this gives us a simultaneous equation. So if you don't know how to solve simultaneous equation, you can just comment simultaneous equation below and I'm going to create a video about solving simultaneous linear equation. So let's proceed further. Here we can solve it by elimination again. If we multiply this one here by 3, the reason we are multiplying by 3, we want to easily eliminate the b part because simultaneous means solving an equation one after the other. We have two unknown in two equations, so we solve for one unknown, then the solution we got from that first unknown, we use it to solve for the second unknown. So that's just it. So when we multiply this one by 3, we have 9a minus 3b equal to minus 3. So we are now solving these two equations now. If we add both of them together, we say that we have 11a, this and this will become 0, is equal to 7 plus minus 3 will give us what? 4. So this is 4. So when we divide by 11, we see that a is equal to 4 over 11, right? So since we have gotten the value of a, we can proceed to get the value of b. So we can say from this equation, let's call this 1, let's call this 2, let's call this 3. So we say from equation 1, 2, from equation 2, we can say 3a minus b is equal to minus 1. Now when I take this minus 1 to this place and bring this b to this place, we have that b is equal to 3a plus 1. Is that clear? Yes. So we can easily say, but we know a as what? A is 4 over 11. So we substitute here. A is equal to 3 multiplying 4 over 11. I will open the plus 1. Come open this bracket, we have 12 over 11 plus 1. So when we solve this, we see that b is equal to 12 plus 11 over 11. So that we have 23 over 11. So we have gotten the value of b as 23 over 11 and the value of a as 4 over 11. So we come and substitute them back here again. Exactly. So if you look, they have the same denominator, that is value of a and b. So we can easily write them as, we got a as 4 over 11 and b as 23 over 11. So say that this is equal to 7x minus 1 over 3x minus 1, 2x plus 3. So this is the partial fraction for this compound fraction here, right? So if you want to make it look simple, I'll just write this over 11, then 4 over 3x minus 1 plus 23 over 11. No, 11 is already out here. 2x plus 3. So this is the partial fraction. So you can just proceed and solve this partial fraction. That means sum them up together to see if you can get this particular solution. But that is to verify that our solution is correct. So I want you to solve this one the way we did the previous one and put the answer in the comment below. Thank you very much for that. So in this video up here, we talked on when the denominator are not non-linear. When you have a compound fraction and the denominator are not linear, that means they are not of this form. Let's say you have a denominator that look like this: 2x squared minus 1 and x minus 4, something like this. You have a denominator, a partial fraction of this one, 7x plus 3. Partial fraction that look like this. These are not linear denominator. This is linear, this is not linear. So in this case of partial fraction, how do you resolve them? So in this video we talked about that. Thank you very much for watching. Subscribe.